In section 7.4, we're going to consider a method here called partial fractions. So this is a method for integrating rational functions, a numerator and denominator function that are both polynomials. So partial fractions is basically least common denominator backwards. It's the opposite of simplification. So let me start with an example to illustrate here. So example 1, we just want to simplify this subtraction of two fractional expressions. So we've got that 2/3 here over x minus 1. And let's leave some space in there, minus 2/3 over x plus 2. And if we wanted to simplify this, we get an LCD. So the LCD is just going to be the product of those two factors. So we want to multiply by the missing factor, top and bottom. So in the first term, that's x plus 2. In the second term, we want to multiply top and bottom by x minus 1, which is our missing factor. And now we've got that LCD in both pieces. So over LCD of x minus 1 and x plus 2. And then in our numerator, 2/3 times x plus 2. And then this minus sign, and 2/3 times x minus 1. So now we want to multiply our 2/3 in and our negative 2/3. So 2/3 times x, 2/3 x. 2/3 times 2 will be 4/3. Negative 2/3 times x minus 2/3 x. Negative 2/3 times negative 1 plus 2/3. And over our LCD here of x minus 1, x plus 2, let's go ahead and multiply that out. So first terms here, x squared. Outer terms 2x, inner terms negative x, so plus x. And last terms negative 2. In the numerator, 2/3 x and negative 2/3 x cancel. 4/3 and 2/3 is 6/3, which is 2. So this is just the expression 2 over x squared plus x minus 2. So why did I do this? Well, sometimes we want to integrate something that looks like 2 over x squared plus x minus 2. And if we could break that down to this, then we'd just be integrating 2/3 over x minus 1 minus 2/3 over x plus 2. And both of these we can integrate. If you factor that 2/3 out, this looks like g prime over g, and the same thing here, g prime over g. So those are both going to be log integrals. So we'd like to be able to reverse this process and find those coefficients. Now the denominators here, those are not hard to find. If you just factor this, FOIL backwards on the denominator, you get those two factors, and notice that those are each the separate denominators in the original version here that's split apart. We need to know how to get those 2/3, and that's the method of partial fractions.